Hi everyone! In the last two videos we talked about adding functions and subtracting functions, multiplying functions and dividing functions. In this video we're going to talk about another operation called composition of functions. So let's return to Annie and her pumpkins. Remember that Annie can pick 4 pumpkins per hour. Now let's add another element to the equation where we say that each pumpkin is worth $2. So the question is, how much does she earn in 3 hours? Well, we could think about this mathematically by saying there's a function that describes how many pumpkins Annie picks per hour, and that's just 4 times t. There's another function, so let's write this, pumpkins in t hours. There's another function that describes how much she earns per pumpkin. We can call that C of P, and C is just the earnings for P pumpkins. So say she's picked P pumpkins and each is worth $2, then her earnings are just 2 times the number of pumpkins, which is P. So it's really easy to think about this problem sequentially. We could say in 1 hour, she picks, so P equals 4 times 1. She's picked 4 pumpkins. So that means that she has earned 2 times $4. So our original input was the 1 hour. Then we did the P function to it to figure out how many pumpkins she got. Then we plugged that number of pumpkins in to the C function to figure out how much she earned. So let's do it for the question for 3 hours. So in 3 hours, Annie has picked 4 times 3 pumpkins. So we first do the P function. How much money is 12 pumpkins worth? We do the C function and multiply that by $2 per pumpkin. So 2 times $12. So essentially what we're doing is we're picking a time, t, and I'll put it in this little bubble. Like when we talked about functions, we said we could think about it as a space of numbers. Then, whatever that time was, we plug it in to the number of pumpkins function. So we end up multiplying it by 4. And that puts us in a set, which is the number of pumpkins. And once we know the number of pumpkins, we can plug that into the cost function to get the total earnings. So we see that when we plugged in t for time, that went to 12 pumpkins, and 12 pumpkins went to $24. So in a way, what we're doing is another type of function. We could have just gone from the time to the earnings, because we could see that for the earnings, C, it depends on the number of pumpkins, which depends on the time. So I could plug in the entire pumpkin function into the cost function. So I'd get 2 times, instead of P, times P of t, but P of t is 4 times t. So 2 times 4 times t. And it's clear from these two examples that that's what's going on. We take the time, we multiply it by 4, that's this part of it, then we multiply that by 2 to get the whole thing. So for example, C, the number of the earnings for 3 hours would be 2 times 4 times 3, which is 24. This is the idea behind composition of functions. So let's write down an example. or let's write down the definition rather. So here's our definition. The composition of f and g is written f little circle g of x. We get it by plugging in g of x for x in f. This sounds a little confusing, but the notation is like this: f of g of x. So instead of having x inside the parentheses, we have this whole g of x, and this is the same as f little circle g of x. Now I'm going to write down something about the domain of this function because we'll need it later, but we'll do more examples later where we calculate the domain. The domain of f composed with g is the set of all x in the domain of g such that g of x is in the domain of f. So what does this mean? Well, let's go back to that picture, a similar picture to the one we drew before. So here are 3 sets. Okay? So when we do the composition of f with g, we first do g, the function g. So this should be the domain of g. Let me get rid of my face so you can see this picture more clearly. Okay. Then we're going to do f. So this set is not only the range of g, but it's got to be in the domain of f also. So this has to be in domain of f because we have to be able to plug these things into the f function. And what the composition does is it skips this set and combines the two by saying first do g and then plug that into the f function. So again, I might have an x here, which is in the domain of g. That has to get mapped into the domain of f by g, so I do g to it. So this is g of x. This is like our p of t from before, the number of pumpkins. Then I'm going to plug that into the f function. So this point is f of g of x, which we also write f composed with g of x. So let's do an example. We'll do more examples in the next video, but I want you to see at least one right now so that it's a little bit more clear. So let's say that f of x equals x plus 2 and g of x equals 4 minus x squared. Then first let's do f of g of x. So I want to compose these two functions, which means I first plug into g, and then I'm going to plug that whole thing in for x in the f of x function. So g of x is 4 minus x squared. So I'm going to do f of 4 minus x squared. So now this stuff is going to play the role of x. So that's going to be 4 minus x squared instead of x plus 2. And we could simplify this a little bit to get negative x squared plus 6. when I combine the 4 and the 2. Okay, let's do the other direction. Let me keep that up there so we can compare. So let's try to do g of f of x. So now in this case, I'm going to do f of x first, and then I'm going to plug that into g. So f of x is x plus 2. So I'm going to do g of x plus 2. So that means I use x plus 2 instead of x. 4 minus x plus 2 quantity squared. And I could multiply this out. This will give me 4 minus x squared plus 4x plus 4. Now if I distribute this minus to everything, I end up with minus, well, I'll do it in more than one step. 4 minus x squared minus 4x minus 4, which is just x squared minus 4x. Composition also works for a specific value, so we could do g of f of negative 2, and I actually have two ways to do this. First, I could do it this way, g of f of negative 2. So f of negative 2 is negative 2 plus 2. That would be g of negative 2 plus 2, right? Then I plug that into the g function, so this is 0. So now I'm doing g of 0, which is going to be 4 minus 0 squared, which is 4. The other way I could do it is I already know g of f of x equals x squared minus 4x from our last example. So g of f of negative 2, I just plug negative 2 in for x here. Negative 2 squared minus 4 times negative 2, which is 4. Let's see, is that right? That's my mistake. This is negative x squared. So that's negative x squared minus 4x. Sorry. So then g of f of negative 2 is going to be negative 2 squared minus 4 times negative 2. So this is negative 4 plus 8, which is 4. So we get the same answer both ways. The next video will show a lot more examples of computing compositions of functions. So hopefully it will just get easier. But what I want you to get out of this is that all we're really doing is plugging one function into another. So the g function eats the f function, or the f function eats the g function. So check out the next video for some more examples.